Right hand side equals 1 on 6, sub it into the right hand side. 1, 2, 3, 6 times 1 on 6 is 1, therefore true. Whatever your teachers want, but that's pretty much done. Easy? Yep. Step 2. Assume true for n equals k. Step 1, 2, and 4 is all worth 1 mark because it's nothing. It's step 3 that's going to be worth everything. So as you're practicing, if you're doing really well at step 1 and step 2, stop doing step 1 and step 2. Just focus on step 3 because you're just wasting time writing this. Assume true for n equals k. That means you write everything the same except
Whoa.
Yeah, relax, man. Poor girl. Step 2. Assume true for n equals to k. Step 3. Prove true for n equals k plus 1. I always taught you guys to write i.e. i.e. That means, what are we actually proving? You're proving this. 1 squared plus 2 squared plus ... plus k squared plus 1 more. Right? Because you're adding an extra 1 plus 1 more. There we go. K plus 1 squared. Do we understand that? Must equal to, then again you replace your n's for k plus 1. So it becomes 1 on 6, k plus 1, k plus 1 plus 1, which is k plus 2, 2k plus 2 plus 1, that should become 2k plus 3 if you have subbed it in correctly. Any questions? Now, is this the first time you've seen this? Oh, as well. Okay. So, all good so far? Sounds good. Nadia, all good?
Yep, I remember doing this earlier.
Yes, you're right. Then, the reason why we have this IE is because, you see all of this? Does that look familiar? All from step 2. It needs to be. So, left-hand side equals 1 on 6 k, k plus 1, 2k plus 1, plus k plus 1 squared. Now, only the students that do the next line, like me, usually get this right. Those who don't, unfortunately, have problems factorizing the next step. Good question. Don't just agree with him like, yeah. Hold on. I.e. Look, hold on. Let's just. But let's explain. What's before the n? What's before n? Good. What's before n minus 1? So then what would be after n minus 2?
Oh, wait.
I knew you were going to say that. That's why. Be careful. N minus 1. What's after n minus 1?
N minus 2.
No, after as in you're adding, going forward.
Yeah.
Sorry. N. And what's after n? N plus 1. So the idea is, if I'm up to k plus 1, listen, if I'm up to k plus 1, what's the one before k plus 1? K. That's why if I'm going to sub in k plus 1 squared, I like you guys knowing the one before would have been k, which means the one before would have been all of your step 2. I just think it makes more sense that way. Does that make sense? So if you're at step 10, but you already have step 9, well then obviously step 10 would have been all of step 9 plus just one extra one more for step 10. Good. So all good with that? Next line. Because you know what you want to prove, where's my thing? There. You know what you want to prove. When you do this, yeah, like that. When you're doing this, you should be copying what you need here. Just like the way I've always shown you to do show questions. You've got the answer in front of you. You've got your working out here. Try to get your working out to the answer. Don't try to get from your working out to something that hopefully becomes the answer. Don't do that. You actually direct it to the answer. What that means is this. I've got a 1 on 6 here. I've got a 1 on 6 here, but I don't have a 1 on 6 here. That's okay. You still factorize a 1 on 6 out. I've got a k plus 1. I've got a k plus 1. Factorize k plus 1. I've got a k plus 2 and a 2k plus 3. I don't have that here. I stop. I'm done. Now, I open my big brackets. What am I left with? I'm left with a k and 2k plus 1. 1 on 6 times 6. And then gives me 1 and then k plus 1. If you didn't factorize the 1 on 6 out, you will have a lot of problems trying to get this out again. And that's it really. I think you guys know what's going to happen. Being at your stage, I'm just going to cheat unless someone tells me I don't understand. Expand, simplify it. It would have been a quadratic, and then the quadratic would have factorized to something like this. Is that okay?
So we will do
Sorry?
the
Yep, has to. Step 4.
we have to put that in this armature.
What do you mean? We just did.
Well, put the quadratic equation.
Okay, sorry. So maybe you didn't hear what I said. Hold on.
No,
This-
I get it, but if you already know mentally that the issues are just
HSC, no. See, your school teachers, which is what I was going to get to step 4, HSC, no. So HSC, you can understand. The way I teach is HSC. Your school teachers, because it's your first time doing this, they've got to assume you don't know what you're doing. So therefore, they've got to mark you down if you're not showing full working out, because you could have fudged them. By the time you come to the HSC, the person that's sitting this could have been an Extension 2 student. Extension 2 students are not really going to expand. They're just going to write the answer because they can see it. So, tricky. You know what I mean? So I don't know. That comes down back to your teacher. You got to talk. Maybe, you know what I tell my students to do? Do this. Just give it to them. Like, would I get full marks? If they say yes, then don't worry about it. Yeah, record it. Make sure they sign it. It's done. That means in the exam, you're fine. That's it. Just be safe like that. Otherwise, some teachers also do this. Like, imagine you guys are doing this. They've never checked your homework, which means you've always done like this. They haven't checked your homework. You go into the exam, you'll do it, and they go, but they'll deduct a mark because they've never done their job and they never checked your homework. But in fact, you've just always done it the right way. Just they didn't check up on your working out and whatever. So it becomes your fault. To avoid that, just show it to them, say, hey, is this right? Are you okay with me doing like this? The answer is yes. Good. If the answer is no, expand one, sure. At least that way they'll know you know what you're doing. I think that's what you want. Step 4, talk to your teachers. I don't know what they want. Cool? Everybody wants something different. So step 4, this is what we want in the HSC. We don't care about step 4 in the HSC. If it's omitted, we don't mind. Because nobody writes it. Like one mathematician said, he said school teachers are like Mickey Mouse. And we were very confused with us when he was teaching us induction. This is a while ago. Like, what do you mean, Mickey Mouse? It's like Mickey Mouse, someone drew it and others just copied. So like some teachers, someone wrote this big sentence for induction, and other teachers have just copied. Fair enough. So reality is in step 4, like me, at university level, for example, we don't write step 4. There is no step 4 because the whole proof is in step 3. So once step 3 is done, you're done. You've proven it. But if you really wanted to, the step 4, that you might learn at school. I will tell you the way to write it, which is the most efficient way. It's still long if your teachers don't accept this. Step 4 will be written like this. Therefore, true for n equals k plus 1. True? Only if it is true for n equals k. But since it is true for n equals to 1, therefore it's true for all positive integers n. So that's probably the best and most logical way to explain it to you guys. Just do it backwards. So you can't be, because you're proving by induction.
No, I'm saying step 1 and then step 1.
You can't be, as I said, you're proving by induction. Yeah.
Well, it is false.
You can't be, you can't. Because
Taking one of those like trick questions.
you can't. Because that means you're not proving induction now. You're disproving, which isn't in this course.
That's what I say.
Yeah, true. Okay. I like it. But anyways, one more time. Therefore, true by mathematical induction for n equals k plus 1, only if it's true for n equals k, because remember, we put that assumption in. But since it's true for n equals 1, therefore it's true for n equals 1 plus 1, 2, 2 plus 1, 3, 3 plus 1. That means for all positive integers n. That's the lengthy one that your teachers like to see. So that I'll leave to your teachers. Leave that. Let's do one more. And if you guys are okay with it, then we'll do a divisibility one. We'll recap it next week, and then we'll just do hard questions next week, the series, and that's it. All right, let's do. Let's do example 6. Let me know if I'm going fast as well, please. Example 6. Okay. Step 1. Test. TAP. TAP was the acronym. Test, assume, prove. Test, true, for n equals to 1. Where do I sub it in? To the last term of the left-hand side. 2 to the 1, take away 1 equals 1. Right-hand side. 2 to the 1 is 2, take away 1 is 1. Therefore true. Step 2. Assume. For n equals to k, 1 plus 2 squared. Step 3. I think Stefan, Ben, you guys remember on Tuesday when I was talking about exam papers and stuff, I was saying, see, induction doesn't have a double I. Remember I found one? There was a double I and a triple I. And the only way you're going to find those is exams. Yeah, that's it. You just need to go and expose. Otherwise, you're going to see it one time and you're like, what the heck do I do? I'll find it. I know where it is. Prove true. 1 plus 2 squared plus ... plus. That's your k. Then you got one more, which is k plus 1. And then minus 1 just becomes k. That needs to become this. I-E. All good? Left-hand side equals all of this, which is our assumption. So 2 to the k minus 1 plus 2 to the k, which equals? How? Yes, you're right. For how? Just tell quickly. One extra step. You're right. I think there would be one thing we would like to see. Yeah, that's the, if you have to probably write 2k minus 1. If you didn't write 2k's, you're struggling now. Because now we don't know if you actually know it through index laws or if you did fudge it. Then since there's 2 of them, then that becomes k plus 1. 2, k plus 1 minus 1 equals right hand side. Make sense, Andy? Yeah. Just got to be careful with that. You're there, you had it. Oh, yeah. All good? And then step 4, like I said, whatever you want to write. Seriously, I can't do that. It's against everything I know. Just whatever. I think sigma's out of the syllabus now. I remember sigma's out. But I still think you should know it, but anyway, sigma's out. Any questions? Let's do divisibility. Have you guys done divisibility as well at school?
Well, sigma in general or sigma in reduction?
Yeah, I think in general.
We don't have series.
I know. Yeah, that's the thing, but I think it's out of the syllabus. No, I actually think it's out. But then, in saying that, so were some other topics that they put in the HSC. So, yeah. I know. So I'm going to still teach it, exactly. And when we do series, I'll still be doing it. But, because I think it's important. But anyways. Proof. Divisibility. What don't you have that you usually have in the other one? You don't have a right-hand side. Because you don't have a right-hand side, you will have to create the right-hand side. Something like that. Equals to a positive integer. But anyways, cool. Divisibility. Type 2 and the only other type. And then we'll just see if I can find the hardest one that I can think of. Okay. Prove that 5 to the n is minus 1 is divisible by 4. All right, step 1. Test true. 4, n equals to 1. So that means 5 to the 1 take away 1. 5 to the 1 take away 1 equals to 4. 4 divided by 4 equals 1. Therefore, divisible by 4. Step 2. Assume true for n equals to k. That means it will look like this. 5 to the k minus 1 divided by 4 needs to equal to, let's say, mp, whatever letter you like. Where m is an I think k is already positive, so you know this is going to be positive, but that's okay. Where m is a... Do I need to say positive? I think it's okay to say it's an integer because it's just saying if it's divisible by 4. So it could technically be negative, it's not a problem. Right? It's still divisible by 4. Like I'm just saying, if it was negative 16, yeah, it doesn't really matter. I'm just...
If n is going to be positive integers, this is in the question.
Yeah, but n is a positive integer, the power of n here.
So n has to be.
It will be automatically, I know what you're saying, but I'm just saying like, I don't think for divisibility in general, I don't think m needs to be a positive integer. I think it just needs to be an integer, right? Because if something's divisible, if I told you negative 25, if it's divisible by 5, it's fine. As long as it's an integer, as long as it gave you 5. But you can write positive integer or integer. Where m is n, I'm just going to write integer. Because I feel like it can be negative. Not in this question, it's in general. So I think in general, then we might as well just write integer. Now, I would have said skip a few lines. Your teachers will go and make you start solving for 5 to the k. The reason why I say skip a few lines because some questions are going to be really tricky. You don't know what you want to sub in until step 3. So do what I did. So just leave it there. Step 3. Prove true for n equals k plus 1. So pretty much you've got 5 to the k plus 1 minus 1. Correct? Now from that, you've got to think about what you're going to substitute. Well, all of divisibility, most of divisibility is going to be index laws. So you can see you can change this to 5 to the k dot 5 and then minus 1. So that means automatically you're going to substitute 5 to the k, which equals to 4m plus 1. Sub that into here. 25, take away 1 is 4, so I get 20m plus 4. Factorize my 4 out. Therefore, divisible by 4. Why is it divisible by 4? Sorry? Yeah, because you're timesing it by 4. Correct. Therefore, divisible by 4. Good, done. Easy. Questions? No? Happy with it? Let's do, I guess, a thrill-seeking one. Done. Well, that looks nice. So we'll try that. That's your series formula that we're going to learn next week. That's again your series formula. We're going to learn next week. So let me just circle the ones I wanted. What time is it? Yeah, cool. We'll do that one. Oh yeah, why not? Let's do that. Let's do some factorials. I don't think in the syllabus for extension 1, I don't think I'll look at it again, but why not do it? Because it's helpful to recap your log laws anyways. 25. Don't think this means complex numbers. I's and J's, don't do that. D1. Yes. Yes. Yes.
Except for the independent.
Yes.
And the independent, it's going to be the same as the independent. So we did the independent with this one. You asked the first, she goes, oh,
That's lucky of you. For you. All right. 215. These look nice and hard now. All right, let's try that one. These are all inequalities, isn't it? Yeah, because that's all extension 2. And then we just write when you see them. Yeah, so inequality came out once in the last like 16 years from that point on. So that's why they just put it into extension 2. Usually it's been a summation of divisibility for extension 1. All right, let's start up here and see if we can do these. Actually, let's go backwards, because I'd rather do a hard one first. So let's see what the heck to do with this n to the 5 take away n. Divisible by 30. Now that means I could get stumped. So don't think like it's only going to be you. It's going to be confusing for us all. All right. Prove that it's divisible by 30. Oh, okay. Step 1, S1, test, n equals to 1. Yeah, has to. So n equals 1 fails. So therefore, test n equals 2. So 2 to the 5, take away 2, which is 32, take away 20, equals 30, divisible by 30, done. Step 2, assume n equals to k. That means k to the 5, take away k, divided by 30 equals m. S3, prove n equals k plus 1. That means k plus 1 to the 5, take away k plus 1. Okay, Sammy, what do you want to do with this? Yeah, I know, right? All right, my first thing, just something that came to my head, is I'm going to factorize k plus 1 out. It could be wrong, let's just see what happens. K plus 1 to the 4 minus 1. I see something. Yeah, you see it as well? Difference of two squares. Yeah, very good. I like it, I like it. I knew I shouldn't expand. I was like, expanding is going to be really weird.
Yeah.
Good, good, good. Let's keep going. And maybe we're getting too happy as well. It could all be wrong. K plus 1. All right, difference of two squares. That could be k plus 1 squared minus 1. And then k plus 1 squared plus 1. Like that. Still good? Equals k plus 1. This becomes k squared plus 2k plus 1. K squared plus 2k. And then plus 1 minus 1 cancels out. We're okay with that? Did I do something wrong? Just double check my working out in case I am doing something wrong. K plus 1 squared minus 1. K plus 1 squared plus 1. Yeah, that looks right to me. This one, k squared plus 2k plus 1 is k squared plus 2k plus 2. I can't see this being divisible by 30, but that's because I've lost track of what we're trying to do. We're trying to get up here. K5, don't forget we have to bring our assumption in. Wait a second. Just try and make it efficient if I can. Which I can't. Can't see any more efficiency than me about to expand this whole thing. Sorry guys. Let's go k cubed plus 2k squared plus k squared plus 2k. So that becomes k cubed plus 2k plus k is 3k squared plus 2k. That whole thing multiplied by that. That becomes k5 plus 2k4 plus 2k cubed plus 3k4 plus 6k3 plus 6k squared plus 2k cubed plus 4k squared plus 4k equals k5 plus 5k4 plus 2, 8, 9, 10. 10k cubed plus 10k squared plus 4k. Fair enough. I don't know. All right. K4 minus 1. K squared minus 1. K squared plus 1. K minus 1, K plus 1, K squared plus 1 equals M. Therefore, K plus 1 equals 30M. Therefore, K plus 1 equals 30M over K squared plus 1, K minus 1. All I had to do was sub it in and then factorize a 30 out. Done. I just saw it. I realized it can't be that, right? It's okay. But I want to see if I could have continued from there, just in case you guys did do that. But I found out what I should have done. I only realized that when I went back up to my assumption. That's okay. It's how it works. Forget, you gotta not say, oh, this is extension 2, because this could be extension 1. You can't think like that. There's nothing to do with extension 2. It's just that it's harder. I'm just trying to, I want to see, would I have got away with it? K5 is 30m plus K. K5 is 30m plus K. K plus 4K is 5K. And then you would have had all these 5s, which means you can definitely say it's divisible by 5. True? You can definitely say it's divisible by 5. That means what must happen in the inside? 6m plus K plus K4 plus 2K cubed plus 2K squared. What must definitely happen in the inside? Well, the inside must be a factor of 6, right? Because then 5 times 6 gives you my 30 that I'm looking for. Let's see if I can somehow fudge this out. Give me a second. Plus K, 1 plus 2K, plus K cubed, K plus 2. No, don't want that. No, can I get it out? I'm trying. K 1 plus K cubed, this one, 2K squared, K plus 1. And then 1 plus K cubed is 1 plus K squared. Nah, it's overkill. Overkill. There has to be a way. Since I found out the other way, I'm just going to rub all this out. Too bad. Go back up. Let's go again. I guess lesson learned. Try to avoid expanding. Always think of simplifying and factorizing. So we had what we had here, this first line. Yes? From up here, we can see that I can get K and then K4 minus 1. And then from K4 minus 1, I can get K squared minus 1, K squared plus 1. From that, I can get K minus 1, K plus 1, K squared plus 1 equals to 30m. 30m. Then I can get K plus 1 as 30m over this whole monster. If I substitute that into this, isn't this whole thing automatically going to be divisible by 30? Because what's 30 to the power of 5? Well, they'll still have 30, and this will still have a 30. By the time I factorize a 30 out, this whole thing will be divisible by 30. That's the only way you can get it out. Probably the most efficient way. Let's not say only way. Most efficient. Oh well.
So we've got 8 lines for that.
We did 8 lines for absolutely nothing. But you know what? It helped us realize the difference of 2 squares. So I probably wouldn't have realized that if I didn't. It's because I didn't. I would have not done this if I didn't actually come up to here and think about how the heck am I going to expand this. Like I said, you win some, you lose some. What can you do? That's it. It wasn't a waste. Some good math. Hurt my wrist a little bit writing that, but we're good. All right. Let's go do a normal one now.
And for the step 4 divide, it equals like it's
For n is greater than or equal to 2.
yeah.
Yes, and that's why I'm going to pick one of these ones now. Like here. Prove this is even. Oh, even. That means it's going to equal to 2k. To prove something's even, what are you essentially proving? That it's divisible by. True?
Yeah.
It's a hidden divisibility. Your divide, it has to be divisible by 2. So just be aware of that. That's a sneaky one. Let's go. Step 1. Test n equals 2. It's even. 9 squared minus 7 squared. 81 take away 49. 89 take away.
But you're saying that it's divisible by 2, so then you still can do 1, right?
Sorry.
One minus three.
Yes, n is even. I mean, sorry, not n is even. The expression is even, which means it's divisible by 2. Ugh, yes, n is still 1. 9 to the power of 1, take away 7 to the power of 1 is 2. Divided by 2 equals 1. Technically, therefore, even. This is even. Or it's divisible by 2. Divisible by 2. Step 2. Or step 3, we're just going to jump straight into it because we can change these to k's. Step 3, 9 to the k plus 1 minus 7 to the k plus, you know what? Let's slow down. Step 2, assume n equals to k. So that means 9 to the k minus 7 to the k over 2 equals m, where m is an integer. Step 3, prove n equals k plus 1. 9 to the k plus 1 minus 7 to the k plus 1. That's it. All right. So, like I said, up here you usually meant to skip a few lines because you're not sure what to sub in. But because I know here you're going to use your index laws all the time, that means that's going to become 9.9k minus 7.7k. Then that means up here you're going to make either one the subject. Obviously the smarter one would be making 9 to the k the subject, because then you can add 7 to the k. There it is. So that means this becomes 9 times 2m plus 7 to the k minus 7.7 to the k. Be very strict with your math like that. You see how I'm writing 7.7? Like you gotta, because I guess the mistake I've seen all the time for these is only like 9 times 7, they write 63. So don't make those mistakes, be careful with that. 9 times 2 is 18, plus 9.7k minus 7.7k. 9 take away 7 lots is 2 lots, and we're done. 2, 9m plus 7 to the k. Therefore, even. Easy?
It was 2.7.
It's not 2 point, it's 2
No,
times.
2
2
times.
times, yeah.
Was it 7 again?
Because 7, so 9 7k minus
Was that minus 7?
7.7k. How did I get 9? You expanded this. Okay, done? Done. We're leaving it there. We're done well for today.